Hi there, I'm playing with some classic computers today. We have an HP85 from 1980. Yeah, it's an old machine, but it still works and it has the usual problem with the tape drive. But before I start with that, let's see what it does and how it does it, and well, explore some features that you probably haven't seen before. In my personal opinion, the HP85 is one of the most beautiful mini computers they ever built. Maybe there are others similar, but it has a clear design. It has a CRT monitor built in, only black and white, but who needs color? We have a tape drive, a tape cassette drive here, and it has a built-in printer, and all in all it's light enough to carry it around. In fact, there was a carrying bag. Unfortunately, I don't have that, but yeah, it was more or less a portable computer system. And unless other computer systems, this has never been designed to be just the computer. It has been designed to be part of a larger system. So on the back side there are some expansion slots that accept additional memory, additional ROM cards, and also interface cards like HPIB, which I think it's still the same like GPIB, only from HP, and that has been used to drive, or maybe still around to drive external devices like spectrum analyzers, frequency generators, oscilloscopes and stuff, all the measurement park you have. And therefore there are also a couple of commands here. By the way, the machine here speaks BASIC, but it has a couple of commands that are probably a little bit unusual. So let's see about this. I typed in a little program because, well, the tape drive is not working. So my only backup is the printer here. The program here is pretty simple. Line 10 clears the screen from everything that was on it before. Line 20 sets the scale for the coordinates I want to draw here. Then line 30 draws an x-axis with an intercept at 0 and a mark every x units, so every unit. And line 40 draws a y-axis to the same coordinates, and then end of the program. And if we run that, we will see this. So it draws x and y coordinates. They are crossing at the 0 point, and yeah, a couple of simple commands to draw a coordinate system for a technical drawing, for any parameters you want to visualize. And that's the purpose of this machine, because yeah, it was meant to be for an engineer, as an aid for, well, people who do measurements and stuff. As you can see, besides of the defective tape drive, this machine is in pretty good condition. It didn't even yellow too much. I think that's pretty close to the original color here. Maybe this one sat in a dark office or something, or in a basement, I don't know. Didn't get much sunlight. Screen is good, printer is good. I still have plenty of paper here. It's quite a big roll of thermal paper. This roll may be not available anymore, but you can use any thermal paper as long as you are able to cut it into the right dimension. Maybe you have rolls of old fax paper or something like that. I even have a non-opened or previously unopened box of new tapes. It's the DC100 from 3M. There are probably other manufacturers who made that. And it says compatibility, Burroughs and Hewlett-Packard, so that's certainly the right tape for this machine. There are also other tapes around, but they need a bit the modification of the tape drive, and that's how these cassettes look like. So I already unpacked this one to find out that the tape drive is not working. So the tape itself, it's I think it's how much? 1/4 inch? No, I think it's a little bit smaller than that. Let me see. We are talking about 4 millimeters. Okay, that's not a fraction of inch, but well, maybe an odd fraction. Then the tape itself has this little wheel here that is driven by the motor of the HP drive. And then from this wheel you may wonder why the tape wheels here are going around. There is a rubber band going around like this. You can see there are some pulleys here and here. There is also maybe something here. Yeah, there is also, well, it's probably not a pulley, but a steel post around one that where the, well, that's where the tape goes around. Ah, yes, okay. The rubber band that drives the entire mechanism goes around here, goes here, goes back. The problem with these cassettes is that the tape, the rubber band here gets, well, it falls apart, and then the whole cassette is useless until you replace that rubber band, which is not so easy to find, but I don't have that problem. I have new cassettes, new from, where is it? From 1989. So they are 9 years younger than this one, but still, they are pretty old. So let's see what the issue with the tape is. I install this foam to keep it open. Okay. What you see here is the tape head on the right side, and on the left side is the drive motor with this aluminium pulley here. And let me see, that's the pulley. And there is the rubber that simply fell off because it should be around this pulley that drives the wheel on the cassette, and there should be a little bit of rubber to make a good grip. Now, normally the rubber gets soft, it turns into a tar-like substance or something. And in this case, I already repaired that a couple of years ago, maybe a decade ago. And I cleaned it off, and I installed this heat shrink tube. And the heat shrink tube is good, but it doesn't last very long, especially when it is mechanically stressed a little bit. So it widened and fell down because of gravity. I should have probably glued it onto this metal wheel, and I think that's exactly what I will try today. Maybe I will also use a new heat shrink tube, well, just because. I'm not entirely sure if the tape drive worked after that repair, but well, we will see, and yeah, maybe we get it working. The tape head doesn't look too bad. It's not a lot of wear. You see a little bit something, but it's also not dirty. Well, I cleaned it, of course, 10 years ago and didn't use it much. So let's see what we can do. Let's take it apart. I just noticed that HP obviously used non-magnetic screw, because I first thought it's my screwdriver. I took a magnet, but it's still not attracting that screw, so I need to remove them with tweezers. Yes, they pretty much look like stainless screws. This is nice, but a little bit annoying when I try to get them out from those holes. As I said before, this is a portable computer, obviously, because it has these cutouts here where you can grab the computer from, well, if it's upside down or if it's the right way around. Okay, I see we have to remove that first. Okay, that comes all out easily. Yeah, that's the trick. Okay, as you can see, most of the volume is for the monitor unit. It's that board, and the CRT connected to the main board here. Then another big chunk is this printer, and I just see we may need a new belt here, because this one really looks bad and it's already falling apart like all the other rubber parts here. And then the main board is sitting here under the keyboard. It's pretty small, it's not much bigger than the keyboard itself. Let's unscrew the keyboard and see what's underneath. Okay, so these ribbon cables here, they could be a little bit tricky, because they look like they're in good condition, but they're in a connector that is, they're just plugged in, so the ribbon cable goes directly into this spring-loaded connector, and if you want to remove it, you have to rip it out somehow. And if the cable is a little bit brittle, it may fall apart, so I try to avoid that if possible. So keyboard screw number 1, also not magnetic as usual here. And keyboard screw number 2. It looks like there are only 2 screws, because here is a hinge mechanism. Yes, it looks like that's all we need. And there is the entire computer. Alright, pretty nice board. All the chips look almost the same. That's certainly RAMs here, the small chips here. Those are most likely ROM chips. Which one is the CPU? That could be a memory controller, keyboard controller, CRT controller. Maybe that's the CPU because it has the largest socket. I should have prepared myself a little bit better, but I just wanted to repair the tape drive. On the PCB here we also see a couple of details you don't see in modern machines. They actually labeled the ground. What is this? +6, +5, so voltage +12. There is also a -5 over here. Of course the HP logo and a couple of test points, 21 and 012. Don't know what that means. Maybe, I guess there is something in the manual about these test points. The red cable here goes, where does it go? Oh, that's the power LED. The red cable here. This goes to the power LED on the front. And well, that's just a little bit attention to details, and it tells me that these machines have been made for technical people like engineers and electronic engineers and other guys like that. And they're also meant to be repairable, so that's why they included these labels here. The CRT controller is there, so they put that on the CRT driver board with a little bit of more logic. You can see the processor, oops, there, with the golden cap. So that's the CRT board here, and the power supply board is here on the right side of the screen with some really big capacitors, smaller capacitors, and they are all original. I have never repaired that power supply, and at the moment it seems it doesn't need to be repaired. It doesn't have any leaking capacitors, at least not one that I could see, and also none that I could smell, because when these capacitors start leaking, there is a distinctive smell like, well, it's more or less like fish. And yeah, you know when you smell it what it is. So there is no dead fish around, or, well, it more smells like fresh fish, but it smells like fish. And there is no fish and no necessity to replace the capacitors. As I said before, the drive belts for the printhead also don't look too good. They have turned, normally I think they are black, maybe reddish, but this is clearly falling apart here. Yeah, you can see how it crumbles. And there is also another belt here that drives the line feed drive. It moves the paper up and down, or maybe only up, only in this direction. Okay, I had to remove the keyboard, and now I need to remove this flat cable here that goes to the power supply board that extends all the way until here, you can see. And it is screwed to the printer and tape chassis here, so I have to remove the entire thing here. So it's a little bit bigger than I thought, but I saw a little trick on a YouTube video. This is a foil from an LCD screen. As you probably know, LCD screens, if you take the screen part, the display apart, it has all kind of different foils to distribute the light. So this is only a matte foil, but it has a good strength. And if I cut it to the right size, it will help me later. So I already cut this side. That fits now into this connector. And I hope that will do the trick. So I make a two-sided tool for this HP computer. So that's how it looks. One for the smaller connectors, yes, and one side for the bigger connectors. They are all the same. No, this one is a little bit larger, but I think it would still work with that tool here. Okay, the idea for this tool is maybe I could cut the corners a little bit to make it easier to insert. The idea is that because these connectors here, they don't have a lever to release the contacts like for example, you find in modern laptops or even in a smaller version in smartphones or so. These have the full strength of the individual contacts on this flat cable. And after all these decades of years, the contacts probably will stick to the contact material on the cable. So if I push this between the contacts and the cable, yes, that fits pretty well. I should be able to remove everything in one go, all together. I'm sorry you can't see that very much. Well, didn't work that good. The problem is we have this right angle here, so it's a little bit difficult to grab the cable, but you can probably see that it already came out a little bit. So I just repeat that, rinse and repeat. At least it separated already the cable from the connector. Oh, that's not the way to do. Okay, it survived. And I ripped it out on the other side here, which I didn't want to do, but if it's already out, then be it so. Okay, so this cable looks pretty good. Everything is still there. It got a little bit of dent here. So I hope the second cable comes out a little bit better than that. Okay, maybe I just, oh, maybe it works when I just pull the foil part here. Yes. Oh, it changes color. It removes the non-transparent part of it. No, maybe that's not so good. Maybe I should insert it with the smooth face against the contacts. Oh yeah, that works much better. So it's advisable to use the smooth face against the contact set. Okay, I leave that in. I don't need to remove that. Well, I just see there's more connectors. That's the printer connectors. I'll try the same trick here, because this is all screwed together. Printer, power supply, and tape drive. Okay, that one came off pretty easy. I think I'm getting experienced in that. Try it again with the second cable. Okay. Here it's also a little bit easier because you can hold the tape here like that and pull everything out. Okay, that worked. Now let's see if there is more cables. Yeah, there is another cable I can see down here. But okay, there is, what is that? Oh, there is a ground connector. That's also some kind of flat cable. Fortunately, I didn't tear it apart. And of course, it also has a non-magnetic screw, which is a little bit annoying. Yeah, okay. Here is the power supply, tape, printer, mechanism, electronics block. You can also see there is another big processor that I think handles maybe tape and printer, or only the printer. Where is that going? That goes to the print head. Yeah, I guess that's the printer part here. We only have the two big capacitors, and 1, 2, 3, 4. That's another one, 5. Yeah, 5 electrolytics. So I think if I have this out now, I will replace them just to be sure. By the way, here we see a date code, September 17, 1981. So that's the birthday of this specific machine. Well, of this board, but let's call it the birthday of the HP85 here. There are also labels, ground, 12 volt. Okay, that's HP proprietary chips. Don't know what they are, but there are lists where you can look them up and see. Well, I think this one has been made by HP, so you won't find any replacement exactly the same. Okay, tape drive. We are still not there. Okay, so that's how this works. Now I've already removed those screws. There are also rubber mounts. They are, well, relatively good shape. Still elastic. Okay, no problems with that. There is another big chip and another HP proprietary one. Okay, that's the motor. Driving the pulley. That sounds good. Maybe could use a drop of oil here. There's another HP chip. I guess that's probably, yes, that's the head amplifier. See, there are the solder joints from the tape head. It has 6, so it's okay, probably it has 2 channels like a stereo head, And I could imagine that they used an actual stereo head from any tape recorder or something like that. Maybe it's a special design, a special width. I think we have two grounds, record and play, ground, record and play. Maybe, well, I say record and play, I say record and read, okay. However, then we have that chunk. The motor here has a little incandescent lamp that shines through a slotted disc to read the speed of the motor. There is also a diode here. I think that's the photodiode, and this is the lamp, and between there is a disc spinning and tells the mechanism how fast the motor is, and that motor will be regulated. It has 3 wires here, thick traces that go around other traces or solder joints. That's interesting. And it goes up to that chip here, so that's probably the motor driver, also on a 81 date code here. Then we have a black and red cable that drives the LED here, so you can see when it is reading. We have a thick ground wire. Okay. A couple of transistors here. Large power transistor. I think they are for driving the motor. Yes, they are. It's only 2 of them. But I think we have a positive and a negative supply voltage. So if one powers or gets power from the negative, the motor turns backward. And if it takes the power from the positive side, it goes forward. So you only need 2 transistors instead of 4. So the tape drive almost repaired itself here. So the heat shrink tube is already in place because I held it upside down. Of course, that doesn't work for a long time. Yeah, I think getting the motor out is pretty simple. No, that's not the screws I need to open. Maybe yes, maybe no. Let's try the 2 screws here. These are magnetic, only the screws with the machine thread are not magnetic. Okay, how is that holding together? I'm a little bit afraid I have to desolder this lamp here. Unsolder. Okay. Yeah, I need the soldering iron for that. By the way, people are asking me from time to time what equipment I use. And for the soldering iron, I use this Weller WS81. It's not the newest model, but it's an 80-watt soldering iron. And what I especially like, it takes about 10 seconds and it goes up to 450 degrees Celsius, and in 10 seconds it heats up and is ready to use. And the second part I like about this model here is that even if the tip is hot, you can unscrew the sleeve here and hold it with your fingers. You don't need a tool, and replace the tip anytime, even if it's hot, without tools, and pretty quick. So if you want a quick soldering iron that heats up fast and tips can be removed without tools and replaced, that's the right one. Okay, let's return to our project here. I hope they didn't make any fancy stuff with that soldering. No, it's just put in there. What is this? Well, I will clean that later. And the second wire. Come on. Yes. I think that is, no, it's not crystallized solder. Maybe it's actually, yeah, it's a little, how do you call that in English? A ferrule, cable end, a metal can there. Okay, so, yep. Need to unplug that first. Yeah. So now you can also see that spinning disc that I mentioned. So there are my heat shrink tubes, and I fear I only have two sizes, too small and too big. But no, I think that one, yeah, that's a perfect fit. It's maybe not the best quality one. Maybe there is another one. Yeah, I think that's a little bit smoother. Yeah, I like this one. And it is probably big enough to make a second layer. And now I have to think about how to attach that to the spindle here, to the metal wheel. Okay, let's start with a clean cut. Okay, I have to trim that after shrinking anyway, so I make it a little bit bigger than necessary. Okay, so question is, where is my hot air gun? Okay, slight modification of my plan. I think it works better when I spin the motor. I'm applying 3 volts. It's a 12-volt motor, so it turns pretty slow. And now it's time to heat that tube. Yeah, almost perfectly. Okay, so that's the same tube as I used before, and yeah, it just goes over it, so that's perfect. Okay, I like it. That probably gives a good grip. Okay. The excess of the heat shrink tube under the wheel is not a problem, but over the wheel here is a problem, because we don't have a lot of, well, in fact we do. It's more like, okay, I will check that later. Let's shrink the tube. Okay. Let's do a close-up. Maybe it looks funny. Okay, I have to remove that to bring it in focus. Is it in focus? I think so. Screen is little on this camera. Come on. Yeah. I always like shrinking the blue part of the flame because it's not that hot, so it's less likely that you burn something. Okay, that doesn't look too bad. Well, in fact, I could just leave it like that because it doesn't touch anything but the wheel in the cassette, but wow, it looks a little bit strange. I think I just cut away this little tower here. Well, let's see if this is a clever idea. How are we going? That way? Okay. Not that the knife flies in my face. Okay, I'm driving the motor with 4 volts only. Okay, that's the first layer. Let's see if we can do that with the second layer too. Yes. Okay. That worked pretty well. It doesn't look too bad. Well, let's see if this is a clever idea. How are we going? That way? Okay. Not that the knife flies in my face. Okay, I'm driving the motor with 4 volts only. Okay, that's the first layer. Let's see if we can do that with the second layer too. Yes. Okay. That worked pretty well. It doesn't look too bad. I think I leave it like that. By the way, is it a good idea to do that? That's the wrong direction. Yep. That's how it works. The whole tape mechanism in my hands. Okay, I think that does it. So, I declare this motor repaired. But I can't continue right now because, well, I first have to repair that. Oops, sorry. I have to repair or replace this drive belt. Yeah, there are already teeth missing here, or almost missing. Okay, this is something for another video, and that's it for today. Thanks for watching.